Good morning to you all. Uh, and the title of our today's webinar is Research and Projects with Products in Mind. In order to share the knowledge under this topic, we invited Mr. Shalika Siriwardhana, who is very familiar with the topic and has huge knowledge about it. I will give you an introduction about Mr. Shalika Siriwardhana. He is a manager projects at the Center for Biomedical Innovations, heading commercialization projects and research in biomedical innovations, and working as a visiting lecturer in business management and entrepreneurship, specializing in the fields of entrepreneurship, management studies and innovation management at the University of Moderator. He also works as a consultant for business development and innovation management. He has worked as a banker at HSBC Bank PLC, the UK for 9 years, working on retail, industrial and business banking, wealth management and investments. He has managed projects related to global training and development platforms of the bank, and also worked at Haley's DPL Group on new product development. So we are going to start our session today, and today's webinar consists of 2 segments with 2 discussion sessions. The first session is about 35 minutes and it's a Q&A session. Again, next we are starting our second segment and it's Q&A session. So dear participants, you can direct your questions to the chat box while the webinar is happening, and we will discuss those in the discussion session at the end of each segment. So let us begin the session now. Mr. Shalika, when it comes to the topic research and projects, most of the research and projects do not end with a product. So what are the reasons behind it, and what are the factors that need to consider to carry research or a project towards a product? Mr. Shalika, over to you.
Okay, Rasanjalee, thank you so much. Good morning, everyone. I really appreciate the RAIS Lab team for inviting me for this seminar and offering me the opportunity. So as you discussed, so it's actually a good starting point for us to start the discussion. So this is going to be a this is not on just like a lecture. This is going to be a interactive discussion. At some point we will have a conversation about the important points that you raised. Why do most research end up just being a scientific research, and what do we understand from projects that are not ending with the commercializable product? So these are the concerns that we need to look at, particularly when we go through the content of the seminar. So let me share the screen first. So in the day 3 session, some of the main points that we are going to discuss is the innovation research projects, because I think most of you are interested in the research, and you will be going forward with most of the scientific research, engineering research, and therefore we need to look at whether the research activities are being undertaken with the proper understanding whether the technology that you develop or the engineering solutions that you develop will end up with the commercial product, because we currently know that there are huge numbers of commercial activity happening. Whether our research will end up in a commercially valuable outcome. So research and projects with products in mind is an area where a lot of interest and lot of enthusiasm is being attracted. So we'll move on to the planned outcomes of our discussion today. As Rasanjalee introduced initially, when we go forward in our research, particularly engineering research, understanding the full potential of the idea, that means where this idea can move forward, what are the horizons that your idea can go. whether your innovations, your research work, all your hard work can end up in a commercially viable product is a kind of an idea. You may have seen within the last couple of days, there have been, particularly in the pandemic, you have seen there are a lot of, there were people inventing ventilators, various types of ventilators, various types of biomedical products came up. Everyone was like so busy inventing various things. So we will look at whether these products are, whether these innovations are actually converted to products, or what happened to them. If they are not in the market, then we will see why they are not in the market. And if you are, I think I have heard from the Race Lab team that most of the engineering students and most of the team members are actually engaged in engineering research. So whether these research can actually eventually fall into a product and a successful commercial agreement. So we'll look at what are the full potentials that your idea has. The second one that we are going to achieve is whether we can build up a product roadmap. That means, what is the roadmap? What do we understand as a map for your product, and how to understand the heights that the product can evolve into. That means once it goes into the market now, whether the researcher should forget that they have invented something and the product is completely up to the businesses, or whether you are having a critical role in determining, figuring out what will happen to the product in the market. So we will look at whether we can see a product roadmap where it leads to in the future. Choosing the starting points. So the biggest question is for students, most of the researchers and students, how can we start? Where do we start now? What sort of things you can do right now while you're already doing your research? It can be undergraduate research, it can be MPhils, PhDs, whether we can start from now onwards and look at whether our innovations and efforts have a commercial future. So one of the key areas that we wanted to focus on this discussion was understanding the potential. Before understanding the potential of the products, I will introduce you the way that we innovate. I think in the last discussion, the previous seminar that you went through, we discussed about the innovation. The speaker went through why do we innovate, how do we innovate various things. Now in this one, we need to look at whether the innovations are producing the right type of outcome, not only for yourself, whether the outcomes are actually benefiting the society. Now you may be doing various types of research in the lab which generate outcomes that may not be relevant to you. So we have got this particular, it's not only a theoretical framework, it's a kind of a practical understanding where innovation can take place in terms of a funnel. I think last time, if you can remember, the speaker discussed about a funnel of innovation. So that means, let me highlight some of the key points here. So there is this internal technology base, that is the organization's internal technology development. For University of Siriwardhana, that will be the engineering research. If it is a company, that will be the R&D center. They will have R&D departments. So there are internal technology base, and also there are external technology bases. The external technology base means innovation and ideas that are coming from outside organization. If you take this funnel belongs to Siriwardhana, your outside technology bases will be University of Moderator, other universities, Slintech. There will be various other collaborators who work with you. So these organizations provide you the external technology base. They have their own technologies. SLIBTech, Sri Lanka Institute of Biotechnology. there will be medical faculties, clinical partners. If it is engineering, there will be manufacturers, software development parties. So all these external people are external technology based. So all these parties will contribute to your ideas, and the ideas will go through this filtration and the funnel. In the funnel, what happens? You will have ideas that are not particularly relevant to your organization. So that means if it is in your research labs, you may come up with various solutions, ideas, and also some findings. Sometimes there may be findings that your research activities will give you, which are not directly relevant to your main research objective, because your research objective while you are studying is a very narrow, specified one. But halfway through, you might come up with research outcomes that are that may be not directly relevant. As an example, let's take an example, something familiar to you. If you develop a sensor, let's say there was this, I hope everyone can remember, there was this gas problem, gas explosions in Sri Lanka. It was a very hot topic, and there was a controversial topic, and there was a presidential action task force to investigate why gas is exploding. So this gas explosion, there were various companies who came up with gas detectors that can detect LP gas. Let's say you actually develop something like a gas detector or some kind of a sensor which can sense a danger. So while you develop this sensor system, it can have software platforms, sometimes image recognition algorithms, various engineering solutions will be there, but all these innovations and outcomes may not be relevant for your research topic. There will be other outcomes that may be relevant to other organizations. Sometimes you might come up with a solution or a software that is more relevant to another organization or another company, another university, another research group outside. So this open innovation model says you don't just throw it in the bin, but you just make sure that this new innovation, new idea is actually given to the external parties. Now this one you can see other firms market. That means if it is a commercially viable idea that is more suitable for an external company, you just ensure that the idea goes to that organization. You just don't throw it away. So that is the open innovation model, which is very important for researchers. And also external internal venture handling. That means if it is commercially viable, we will actually discuss what is commercial viability, how do we establish the commercial viability. So if it is commercially viable, you can actually even go and start a business. So in our university, in the University of Moderator, there is a startup group, startup arrangement where the students or the researchers Can everyone hear me?
Yes, sir. Hello, Mr. Shalika.
Yes.
Yeah, we can hear you. I
All
hope
right.
so.
You can see the screen as well, right?
Sorry?
You can see the screen.
Yeah.
Okay. So the idea was whether we can me just minimize the screen. So we can make sure that the ideas are utilized, not only by your organization, but external people can also benefit from it. Actually, Tesla Corporation is doing that. They have R&D center. Their ideas are actually, if it is not directly relevant to you, they give the ideas outside as well. Finally, what happens when the idea is commercially, when the idea is suitable to you, if the idea is the final outcome that you have been expecting from your research, it can go to your current market. Now, your research activities might not be market oriented. They will be purely academic, but we will look at how do we assess the ability for you to make a commercial outcome of your research. This is the biggest question that we had. Why do most of the ideas end up being just research? Why don't they go out and make a business in the actual markets? So the funnel of open innovation means you are open to outside, your ideas can go outside as well. Finally, you end up with the final research outcome. That is also something you can think about commercial outcomes. So we will move forward and see what are the special considerations. So you have, the question was whether we have an application in mind. Now, some of you may be developing various algorithms. Some of you are actually developing ways to do image recognition. I know a few of my friends actually, some of you are engaged in building up sensor systems to detect something. So all these research activities are having a lot of scientific outcomes. But whether the scientific outcome is relevant to the market is a question. So one of the things that we are looking at is whether there is a similar technology or a mechanism or a product in the current market. So for you to do that kind of an evaluation, there is something called the market maps. So I'm not going to explain market maps very deeply. It's easy to understand, very easy. What you have is what you have are like two axes. One thing is one parameter, the other one actually checks the parameter, a second parameter of the product. Now in this case, there is a comparison. I just took it because it's easy to understand. Sportiness, how sporty it is and how classic it is. So there is a continuum for vehicles. It's easy for you to understand because the cars are familiar. Now if you look at the sportiness of a car, classicness, Ferrari is at the top. But if it is very practical, that means the car is not for very flamboyant things. Whether the car is very practical, very conservative, that means it's reasonable for only for the purposes. There are various brands of cars that you can see. Now, according in the same way, when you develop technologies, when you build various technologies, you can do a market map just in the same way. As an example, instead of this thing, you can have cost. On the other hand, you can have speed of the technology. If it is a gas, let's say if it is a gas sensor, whether the cost is high, whether the speed is high. Sometimes there will be slower ones, cheaper ones, expensive ones, and fast ones. So you can draw this map and see whether the existing products in the market can fit into this market map. Because you need to see when your innovation goes into the market, there are existing products, whether you can compete with these existing products. So what you do is you draw the market map, locate all the products available because you are going to, there will be quite a lot of competition for most of the products in the market. So you locate all these products and brands into the map and see whether there are empty spaces. Now, in this one, you can see there is some empty space here. There is empty space here. A sporty practical vehicle. It has a space. That means there is a market opportunity. All these empty spaces means market opportunities. Now there is an opportunity in this one. Sporty but practical. That market gap can be filled by one of your innovations. Even if you place anything into this one, smart measurements, remote measuring devices, computer-based, artificial intelligence-based sensing systems, because I'm taking this sensing as an example because it's easy to understand. So all these existing products can be located into the map and see whether there is a gap. If there is a gap, then there is an opportunity for you to develop your innovation into a product that can go and fit into the gap. Therefore, there is a market opportunity that your product can have in the future. So this is a sort of a technique where application-oriented innovation can be done. So what happened in summary, I'll tell you what did I discuss in detail. You build a market map, locate the existing technologies and products in you can use two continuums, separate ones, cost and speed, cost and accessibility, the features and cost. So you can use any of these axes and locate the existing products and find a gap. If you produce your innovation-based products that goes and fits exactly into a gap in the market, your product is more commercializable. So that is how you understand commercializable innovations. The other one is, as I mentioned, the pastille factors. Pastille factors is predominantly, I think most of you are familiar with the pastille factors, the factors in the market. Basically, the pastille means first one is the political factors, economical, social, technical, technological, ecologics and ethics. That means whether it's environmental friendly, ethical. Now, there are certain ethical concerns that you produce and also legal factors. So when you look at the existing market, what are these conditions in the market? So these are non-technical, mostly non-technical features, whether these things are changing in the external market. As an example, currently there is a high inflation. So people are looking at cost-efficient methods. So cost-efficient means economic problems. So this second E in the pastille factors, the second E is for economical. So when you look at the society, there is an economic issue in Sri Lankan society. But if your product, if your innovation can provide a solution to that economy, the උදාහරණයක් හැටියට අර පොල් කටු වලින් පත්තු කරන ලිප. You may have seen there was someone who came up with a coconut shell based cooker, but it gives a blue flame, almost a blue flame with some combustion technology. So they are providing a reliable solution for the current economic climate. So your innovation is commercially viable because it provides a solution for the current economic crisis. And also you may see there is a huge energy crisis in Sri Lanka. Huge queues in gas, petroleum stations, gas outlets. So therefore, there is a demand for energy efficient solutions for cooking, for heating, for traveling. Still, the electrical vehicles are not that much available in the roads. So this energy crisis, it's a technological crisis. If you can provide your innovation into a product, if you can convert that into a product that fixes one of these issues, economic or a social problem, then it can become more commercializable because you have understood that there is an issue. So all these factors can be evaluated. SWOT presentation, that means your strengths, weaknesses, opportunities, and threats. It's quite similar now. If you look at the opportunities available these days, low cost solutions, and also if there is energy efficient solutions, these are opportunities. Threats, one of the biggest threats is US dollar crisis. Now for engineers, you may not be looking at these things in the lab, but the US dollar problem, the rupee dollar problem is a massive problem to Sri Lanka. So what happens, you may find it very complicated to order things from outside, importing things. So if there is a solution you can provide that may use local raw materials, let's say your innovation involves something which can utilize local raw materials. So these are local raw materials. If you can convert these locally sourced items, so that's a threat, but you use the threat to convert some of your innovations into solutions that fixes that threat, then that will become sort of an innovation. Now I have put the picture of a tea plantation, tea pluckers. Tea was one of those, they had this issue of fertilizer. Now, if there is fertilizer, a solution that you can provide for fertilizer or labor shortage, these kind of, let's say there is an engineering solution that can pluck the tea automatically, electrical tea plucking system, then you can minimize the operational cost. That will fix an existing issue in the society. So you understand the threats, but you fix that problem. So this is sort of a something which is familiar to you. In the last days of the pandemic, there was one of these, I think this is the Codgen ventilator, the company which made the Vega. So this ventilator, you may have seen there are a lot of people who invented ventilators in the pandemic. People are dying because of ventilator problems. So a lot of engineering and non-engineering people came up with ventilators. So this is one of the ventilators that came from our own engineers. So push and pull factors means whether there is something in the society pulling you into an innovation. Pulling means society needs your innovation. Pushing means you innovate and try to see whether it can go into any application. But in this one, in the pandemic, there was a very strong pull from the society. Because when there is a high demand, now ventilators was in high demand. So if you have been able to invent one of these pieces of machineries, if you can build the technology behind it, because it has all these mechanical elements, software, sensor system, safety, data recording, all these things are together. So if you can understand the demand in the market and produce something that fits into that demand, so your idea can become commercializable. So these ventilators are very expensive, and it also solves the foreign currency problem, because you make it locally, you test it locally, and it is highly required by the hospitals. So these are innovations that directly go into commercialization. Second one is, what are the priorities in the industry? Now, there are priorities in the industry at the moment. Currently, most of the industries in Sri Lanka have a priority of minimizing imports, because the government has a US dollar problem. So when it comes to imports, a lot of people say, oh, dollar So US dollar problem is affecting everyone. So people are trying to make things with anything available. Now you know there is a priority in the world, in the industry, in the market that foreign currency is a problem. So if there is an innovation, let's say your research work is oriented towards minimizing the dependence of US dollars and imports, that will be highly appreciated. So this is how you figure out whether your ideas are commercialized. Let's say your idea is completely dependent on imports, entirely dependent on imports, you will struggle. Your industrial partners will struggle. When it goes to the manufacturing, everyone will struggle because it is highly dependent on things that are not available. Next one is the flexibility and the versatility. Flexibility and versatility means how much of variations that your products can take according to different requirements. How much of variations that it can take. When it comes to variations, it can be the cost, features, and the market. Versatility of the product, whether you can provide cost efficient. Now, you may have seen there are certain products, gas, as an example, LP gas has a smaller tank. It is smaller and it's okay for people who can afford a very small one. So that's an innovation. That small gas tank is an innovation which is cost efficient. And it is flexible because you have various sizes now. Your product has different sizes. And it fits into that particular market. So your ability for your innovation to fit into different markets, various markets, will be a kind of a very, very good advantage. As an example, if you develop a sensor platform, whether it can be used in automobiles, medical, domestic, industrial, defense, military applications, if it can be used in various industries, then your innovation becomes versatile. So you need to look at the ability for you to change the product using the innovation, whether the product can be offered in various ways. The next one I want to, this is a very interesting topic. The product life cycle. Now, you may have an understanding about the innovations, but when the innovations go into products, the world works in a different way. The world works in a kind of a special way. Can someone, is there anybody who knows when did the first electric vehicle tested on the roads? World's first electric vehicle. Anybody? Anyone who has got an idea? When did the first electric vehicle? At least around what period? So basically, the first electric vehicle was tested around 1908. That means more than 100 years ago. But still, the electric vehicle is not something that you can see regularly. It's one of those, no, that's, yes, good try, early 2000s, but for the first electric vehicle wasn't in 2000. The first electrically driven vehicle was tried in 1908. Then 1912, 1914, that period they tried electrically driven horse carriages. Horse is gone, only the carriage is there. Electric trains, battery operated trains, battery operated carts, battery operated motorcycles. They tried all these things before 1920. It's quite amazing, but if you look at the history of electric vehicles, if you go online and read about it, they have been trying these things. But still, a country like Sri Lanka cannot have it. Sri Lanka, even if we have it, we have electricity problem. So what happens? These products internationally, when there are innovations, there is a pattern that the world works, various countries. So this, if you look at the curve, the dark gray curve, the country where the new product is launched, that means there is a country which actually invents it and it launches. So at the early stage, the country will, now the top part is exports are higher, the lower part is imports are higher. They can't produce, they import. So at the beginning, most of the inventors, they export the product. But when it comes to Sri Lanka, we only get the matured product. Let me highlight that area. Only the matured product. Now, after the invention, this is the invention. After so many years, the matured product will be there. This country now, Germany, let's take this German electric vehicles. So initially, they have been testing in Germany. So German had been exporting this kind of products for years. Only the matured product, even German electric vehicles are not in Sri Lanka much. There is this small BMW electric vehicles, still you can't see much. The country who invents, they export it at the very beginning. Then developing other advanced countries, such as now we have got Sweden here. Sweden initially has imports. Now this part is imports, but later on it has exports. After some time, that country also starts export. But Sri Lanka, this is the exporting part. We haven't even got there. Electric vehicle we can't even export we can't export tea at this moment. It's struggling. So the countries who have invented these things have already started exporting. Then the other countries join, other developed nations join this race of technological. I'm talking about technological things because we are engineers. So technological exports are happening outside Sri Lanka. So as engineers, when you build up all this research work, you need to look at which are the countries who are already in the business. Now let's say Sri Lankans are looking at apit hadala apit vikunana. We are here. So Sri Lanka, let's say Sri Lanka is currently importing, but we want to export. This is the point where we export. This break even, this part is exporting. When we try to export, other countries have already gone so far, and the innovators country has already stopped production. But Sri Lanka is trying now. You can remember Sri Lanka was trying to build Volkswagen vehicles in Kuliapiti. Let's assume that factory is there, but the technologies and the engineering innovations have already started, and they are actually currently shutting it down. You may see a lot of countries are shutting down their diesel vehicle plants. Diesel vehicle production is been shut down because of environmental concerns. But we haven't even started assembling any vehicle except a few. So that's why you need to be careful when you do engineering innovations. Outside world may have gone a bit far. So your innovation should match what is happening outside the world other than Sri Lanka. So understanding where this particular, let's say if it is gas sensors, an algorithm, a software, an energy efficient housing system. I have spoken to some of your friends regarding these solutions, energy, solar powered something. All these things are already there outside in the world. You need to look at what is the exact position the world is in terms of your innovation. Because as soon as you invent it, if a similar one or a more advanced one will be outside Sri Lanka, so you need to compete with those things as well. So international product life cycle is something you need to understand because it is lying completely outside our horizons. Then we will look at a kind of a very quick point that most of we miss. This is the missing point. These days, this topic has become more controversial because of the government's policies that affected various production sort of thing. The demand model for competitive advantage of nations. Now, not demand, this is the diamond model because it looks like a diamond. We call it the Porter's diamond model. You can refer to the particular book from Michael Porter, The Competitive Advantages of Nations. So this is the country specific issues that engineers will face. Now you guys are inventing various things at these labs, doing research, trying to find out undergraduate research, postgraduate ones, but we are operating in a country within the country's framework. So we have to face the complications and the climate that the country is facing. Now, Michael Porter, this is a well-established model that a lot of people appreciate. So, the model says for a particular industry. Now, let's say you are planning to introduce your innovation into a product, because our topic is product oriented. So you are planning to introduce this into a product. So that product will have to operate in the business market. There are 4 things that have to be managed very carefully. The first one is the strategy of the firm. Because universities don't manufacture, you have to go to outside organizations for industrial collaborations to do the manufacturing. Now, Slintech, if you can remember, Slintech introduced this nanographene production. Slintech is not a manufacturing facility, so they had to go to Bogala graphite plant and find out whether Bogala graphite can be converted into nanographite. So they had to consult a financier who is LOLC, and they had to create a separate entity. So the strategy of a firm with whom that you collaborate should be extremely oriented to your intention. Fortunately for graphene in Sri Lanka, LOLC Corporation was the firm's strategy and the structure was suitable for that innovation. So the firm's strategy means the collaborator's strategy should be in line with your innovation requirements. So if you're going to innovate and compete in a product, firm has to be ready for that. The demand condition means if there is a local demand for your innovation. As an example, if there is now currently, if you introduce an energy efficient cooling system, let's say air conditioning, energy efficient air conditioning, that will be there will be suitable demand in the country because everyone is struggling in terms of cost, energy, and heat. So if there is a local demand, it's easy for you to commercialize. The third one that is been proposed in this model is related and supporting industries. Related and supporting industries. Let's assume that you are trying to build a particular item, engineering item, but you want to do the laser cutting. You want to do CNC machining. You want to do 3D printing. You need to do 3D scanning, manufacturing, plastic molding, software development, software testing. All these things have to be done. So there should be other people in the country who do that. So this is what we call related and supported industries. So if the country, if Sri Lanka is having sufficient people who do various things, it's easy for you to do it because when it goes to the industry, they will have ample amount of collaborations. Now, you know, garment industry is well-fledged one except for raw material production. But if you take biotechnology, genetic engineering, nuclear, if let's say you are introducing a nuclear reaction, Sri Lanka doesn't have nuclear reactors, although there is atomic paramanu balashakti adhikariya kiyala tibbata, you don't have atomic reactors. So that means related and supporting industries don't exist for that kind of engineering innovation. So you need to look at whether there are sufficient amount of collaborators, associated parties who will do these external activities. Because you can't do everything. Companies don't do everything. They need to collaborate with various people to do that. The final one is factor conditions. What are the factors? Factors of production. As engineers, you need to understand the factors of production. Labor, machinery, raw material, technology, finances. Someone has to finance your products, projects, commercialization. And also, you need to have sufficient amount of regulatory authority. Therefore, Sri Lanka, there has to now. I remember there were some researchers who were building drone technology, but there was, after the East attacks, there was a law that restricts the flying of drones. Still, you can't fly drones everywhere. So the drone projects get hampered. So the factor conditions are not favorable for these kind of things. So you need to look at whether Sri Lanka or any country, it doesn't matter whether you can go to for your PhDs in other countries, but you need to look at whether the country is having sufficient factors. Easy labor, easy access to finances. Some countries, there are people who will finance your products. Kickstart finances, labor, technology, machinery. There are machinery, raw materials, and also qualified people. Now, Sri Lanka, there is a good thing, engineering wise, there are qualified students. You can find interns, you can find A-level students, you can find graduates, lecturers, professors, consultants. This consultancy, human element is there. In Sri Lanka, there are a few issues such as you don't find machinery in certain things, you can't find financing people. A lot of investors are not financing these, it's only a few. So factor conditions need to be looked at for your invention so you can actually commercialize this. If factor conditions are very favorable, it's very easy to commercialize. Let's say one of the large companies in Sri Lanka, Haley's or Unilever or any company is ready to invest. LOLC is ready to invest in various engineering projects. Because of this availability of financial factor, it's easy for commercialization of various things. So as engineers, you need to look at whether your innovation is in the right climate of these factor conditions around the country. So that's what we call the diamond model. And chance is there anyway, the luck has to be there. The government policies is also on the side. So the chance and government are there, which can be volatile, but from your side, you can make sure these factors of production. 5M means men, minds, machinery, materials, and money. Plus authority. A is authority, should be there. Supporting industries should be there. If you have control on these things, then it is easy for you to commercialize. If you don't have control, then there is a concern for your commercialization. The next one is a quick snapshot. Whether the value chain, that means we introduce something called the value chain. That means how do you convert your innovation. When the innovation goes into a product, there will be a production process. In companies, there will be a production process. If it is a service that you're introducing, let's say you introduce a patient monitoring service. So that service itself has various inputs and outputs. We need to look at whether this value addition process, this is the value chain is value addition by step. Inbound logistics, we have, I will highlight, inbound logistics means the process of raw materials, your main operation in the factories, the delivery process outside, marketing and sales, and finally service. And the companies will have their infrastructure, There are human resources. These are supporting activities. This is the structure of an organization who will undertake your research ideas and commercialize. So we need to understand their problems. Now, technology, if you take supporting activities, the technology development I mentioned here is the R&D. The company who will undertake your research has to have proper R&D. Because your idea is technical, it has to grow technically. So if the company is having R&D, it's a very good value chain suitable for you. I have just taken examples. Inbound logistics. Now inbound logistics is shipments coming to Sri Lanka. Huge problem these days because a lot of even essential items are not being cleared these days for inbound logistics. For our purposes, if you want to convert your idea into a commercial operation, that company has to have sufficient inbound logistics operation. So you need to check whether bringing raw materials is an easy task for that organization. So these are concerns that will affect your activity. Finally, I have mentioned whether the customer service, the after-sales service, engineering products will have special after-sales service because there will be technical services that you need to produce. Sometimes customers will ask, "Meka weda karanne kohomada? Meka kadunot mokada karanne?" So all these questions have to be answered by engineering experts. So when you invent your product and commercialize it, how do we provide the training? What are the instructions? How to do the problem solving? Because your product may not be the perfect. You have to provide certain solutions to customers. Whether it can be customized, how do we do the repairs? All these things have to be considered because service element is important. And finally, we will look at, when we talk about the margin, that means the profit margin, whether we are looking at the affected, underprivileged people in the country. Because at the end of all the research expectation, our vision should be to serve the society. I don't think any of you are producing military grade innovations. Bomb test karanne. So these are like non-humanitarian products. But if it is something that can benefit poor people or general society, that will be highly appreciated because your innovations will have a social impact. So your profit margins should be considered that is not ripping off the society. So your product can actually have an innovative part which gives a reasonable profit margin, such as low cost solutions. If you can invent low cost solutions, it can go into affected people, poor people who are struggling in the society. So that will have a very good social impact. So your innovations can always have, although the commercial impact is there, your commercial impact will be more valuable because you have social impacts as well. So this is why we understand how these elements of the value chain should be manipulated. So that's the first half. I actually give you a snapshot of the history. So we discussed the open innovation model. When we open our innovation, it's easy for us to collaborate. Then we discussed how do we find an application. One thing is we make market maps and see what is there in the market. Then we look at pastille factors, social factors, political, economical issues, technological issues in the country, legal issues in the country. There are legal problems. All these things always give you an idea what to innovate at this moment. Now, Sri Lanka is having a lot of issues these days. It's a very good time for you to innovate and produce commercially sensitive products because commercially there are a lot of issues in the country. That's why you need to understand the pastille and also strengths, weaknesses, opportunities, and threats in the society need to be understood. Then we discuss the push and pull factors. Why do we need to analyze what is needed in the society? what are the priorities currently the country is having, and whether your products can have flexibility to fit into the variations in the market. Then we discussed internationally, locally and internationally, there are various products already existing. So when you innovate, let's say someone is saying, "Api electric car ekak hadanawada," but the electric cars have been there for the last 110 years. Where are we now? Because the world has moved so fast. That's what we call the product life cycle. When you introduce a product, it goes into the life cycle, and you will be in a position in the life cycle. What can you do from that position? Electric car, whether that country will accept it, or whether we just don't sell it, whether we use it in-house. So that explains whether your product fits into the life cycle of products around the world. Then we discuss the factor conditions, whether your product is having any competitive advantage in Sri Lanka. The strategy should be there in the firm. There should be some kind of a demand, at least locally, whether there are related support operations and various factors. 5M factors are there for production. We call it factors of production. And also the government. I'm not going to comment whether the government is supporting these times. They are also struggling. And yeah, there's a chance you can actually take, but the chances can be higher if you understand it and pitch your product in the right way. Then in the first session, we discussed about the value chain, because your product will go through a value chain. Now, in your last seminar, we discussed how your invention goes through. That's called technology readiness levels. But that's how the idea goes into a product. But this explains how the product goes into the market. This is the value addition part of the product. This is purely commercial. What are the activities happening? So if you can understand and make the product which is suitable to do the value addition, then your product is more commercializable. So those are the things for the first session. So the first half is open for questions.